We're fixing to do the autonomic nervous system. And typically by the time we get here, I say to you, now that you know everything there is to know about the general nervous system, what we're going to do is approach the autonomics more as how they differ from the somatics, okay? Remember our fundamentals chapter, the first one we did? And I said this is about all of the parts of the nervous system? Well, yes, it was. This one, the autonomics, we're going to approach it more by how it differs from the somatic nervous system, the ones we just finished. You with me? Okay. And y'all going to get mad with me because I'm going to pound and pound and pound and pound and pound about some things, but you got to understand this. So we're going to compare our autonomics to our somatics. And this is that little thing that I just gave you. We can compare it in different ways. Firstly, by their effectors. The autonomics, the effector is smooth muscle, cardiac muscle, and glands. In the somatics, the effector is skeletal muscle. We can look at the differences. We can compare the efferent EFF pathways and their ganglia. In the somatic nervous system, the motor cell bodies are inside of the CNS, and the axons extend from the CNS out to the skeletal muscle. There is no motor ganglia in the somatics. The sensory ganglia is in the dorsal root. Remember our dorsal root ganglia? Go with me? Okay, stay with me. We're going to see. We done covered 4 test questions. 4. Okay, you with me? Okay. Huh? Points. We're comparing the autonomics to the somatics. And that little sheet I gave you tells you different ways that we can compare it. We can compare it by its effectors. The effectors of the AMS is smooth muscle, cardiac muscle, and glands. When we say effectors, does that ring a bell? What is an effector?
Away. Sensory toward
position.
Oh, shit.
I don't remember.
The effector is what it controls.
That's right.
Okay? The effector is what it controls. The autonomics control smooth muscle, cardiac muscle, and glands. The somatics control skeletal muscle. With me? Okay. We can compare them by their efferent pathways, those pathways that are going away. The somatics, the motor cell bodies are in the CNS, and the axons extend from the CNS out to the skeletal muscle. The somatics have no motor ganglia. The sensory ganglia is in that dorsal root ganglia. The autonomics are all motor. Autonomics are all motor. The autonomics are all motor. They have no sensory side. They use the somatics sensory side. Motor neurons, remember, have 2 neurons in a chain. The preganglionic neuron is inside of the CNS. The preganglionic neuron synapses with the postganglionic neuron outside of the CNS. You with me? All right, now we're going to do this. We got autonomics, all motor. 2 nerves in a row, 2 neurons in a row. We have a ganglia that's inside of the CNS for somatics. For autonomics, the ganglia is outside. It's out in that. Remember up in the lab tonight, we looked at that sympathetic ganglionic chain right next to the rib cage by the vertebral bodies? Y'all remember when I said in lab tonight, I'm gonna say, remember this damn picture, right where the ribs and the vertebral body is? Remember that? That's a ganglionic chain, sympathetic ganglionic chain. In the autonomics, the ganglia is outside. In the somatics, the ganglia is inside. With me? Now, some terms. Listen to me. Don't look down. Don't look back. Listen to me. The ganglia is where the synapse is. With me? Synapse is inside the ganglia. So there's two terms that you got to know. The pre-ganglionic neuron and the post-ganglionic neuron. With me? The one before the ganglia, the one after the ganglia. That good? The synapse in the ganglia. So now we have presynaptic neuron, postsynaptic neuron. Same as preganglionic, postganglionic, same terms. We're going to screw with your head on this chapter, okay? Preganglionic, presynaptic, same neuron. Postganglionic, postsynaptic, same neuron. You good? Synapse is in the ganglia. Synapse is in the ganglia. Synapse is in the ganglia. You with me? Now we're going to change where those ganglia are in a second. But presynaptic, postsynaptic, preganglionic, postganglionic, same. The synapse is in the ganglia. In the autonomics, the postganglionic axon goes out to the effector. So what's the effector of the autonomics? Smooth muscle, cardiac muscle, and glands. With me? The autonomic ganglia are motor. Another way we can compare them is by their neurotransmitters. In the somatic nervous system, the neurotransmitter was acetylcholine. Remember that? Remember our neuromuscular junction? Go with me? Somatics, neurotransmitter, acetylcholine. In the autonomics, there are two, acetylcholine or norepinephrine. In the somatics, acetylcholine always excited the postsynaptic cell. Remember that? Okay, look at me. In the autonomics, we drew a neuromuscular junction up there. Remember that? A bouton come down to a muscle sarcolemma, and the acetylcholine was released, and it excited, it caused an action potential to be generated on the postsynaptic cell. In the autonomics, acetylcholine can either be excitatory or inhibitory, depending on the receptor plate. You with me? No good? So in the somatics, it was always excitatory. In the autonomics, acetylcholine can be either excitatory or inhibitory. Norepinephrine can be either excitatory or inhibitory, depending on the receptor plate on the postsynaptic cell. You good? Mark that shit down, because if you don't understand this, you're going to miss all the questions from here on. You good? Okay, so in the autonomics, the postsynaptic cell, the receptor plate on the postsynaptic cell, determines the effect. There is some overlap of function between the autonomics and the somatics. Some higher brain centers regulate and coordinate skeletal and visceral motor output. Nearly all of the spinal nerves and lots of the cranial nerves carry some somatic and autonomic fibers. So the fibers gets mixed in those spinal nerves. The two systems are integrated. Skeletal muscle activity causes changes in the viscera. No good? Skeletal muscle activity can cause visceral. We got parasympathetic and sympathetic nerves that go to our stomach. And they're controlling the activity of the stomach. If I eat dinner and then get up and go for a long walk, does that activity also control my stomach? So there's an overlap in the functions, okay? There's an overlap in the functions. The two systems are integrated. Now, there are two divisions in the autonomic nervous system, the sympathetic and the parasympathetic. All of the glands and some muscles receive input from both divisions. The parasympathetic is our resting, digesting, housekeeping D system. D stands for digest, defecate, and diuresis. To make it a little bit simpler, the parasympathetics typically inhibit things. The sympathetics are our fight and flight, our E system, excitement, emergency, embarrassment. The sympathetics typically excite things. Go with me? There are some exceptions, but the parasympathetics inhibit, the sympathetics excite. Most of our viscera get supply from both divisions, but one of them is always in charge. They balance each other out, but one of them is more active. And the one that is more active, we say has tone. So if the sympathetic is more active and it's in charge, then we have sympathetic tone. If the parasympathetics are more active and they're inhibiting more than the sympathetics are stimulating, then we have parasympathetic tone. With me? Does that make sense? Make sense? Did I lose you? Did I lose anybody else? I know I lost her. Okay. A chunk of small intestine. It gets sympathetic. It gets parasympathetic. One of them is in charge. One's more strong than the other. Okay? And we call that tone. If the sympathetic is strongest, it's sympathetic tone. If the parasympathetic side is strongest, it's parasympathetic tone. With me? Okay, just to make that come home to you. Our heart, sympathetic or parasympathetic? How many say sympathetic?
Both.
How many say parasympathetic? Which one's in charge? What the rest of y'all say? Parasympathetic. We hold our heart rate down. And if we die and lose parasympathetic, we go into fibrillation really fast. So if the parasympathetic's not there, the sympathetic kicks off and faster. With me? Does that make sense? So the receptors determine what the effect is from each one. But most of the time, there's going to be some exceptions, but most of the time, organs get supply from both sympathetic and parasympathetic. Okay, two more test questions there. Now, the autonomic nervous system anatomy. We need to be able to distinguish between sympathetic and parasympathetic innervation. And we can do that in three ways. So we're going to compare our sympathetics and our parasympathetics.